Hey yo, what's oh wait. Oh, that doesn't matter, right? Hey yo, what's up, YouTube? It's your boy JOSHABRAHAM. And we're starting with the fourth assignment for biological sequence analysis. And this time it looks like it's not related to Python. What's this about? Is this related to Python? I am a total beginner to this. Why is it flickering? So, because this looks like coding, but actually it's not primarily about Python. What the question is about, the Needleman-Wunsch algorithm is method used for bioinformatics to compare to what? Two sequences and find the best possible alignment between them from start to end. That's what global alignment means. Optimal global alignment, local alignment. Okay, these two are local alignment. I do remember local and global alignments. Day 9, day 10. Mm-hmm. Mm-hmm. I got a notification. Oh, one of my videos is banned. Delete. Yeah, delete, delete. 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 Yeah. Your job is to compare them and find how they best align. If you're allowed to match identical letters, mismatch when letters differ, insert gaps like dash if one sequence is shorter. Conceptually, no coding yet. We use scores match plus one, mismatch minus one, gaps minus one, since they said linear gap penalty. Then we fill a table that shows the best possible scores for aligning every prefix of sequence 1 with every prefix of sequence 2. Not gonna lie, I forgot what the prefix is. Prefix, suffix. Prefix is like something you add before the word, like add in front of the word. Suffix is something you add at the end. Finally submit. Okay, so I don't have to do Python this time. I'm gonna ask to do it on paper. No, it's not asked to do it on paper. Okay, okay. How do I start? Now, if I'm doing my hands are cold. Let me wash. Let me heat it up. Match, mismatch, gaps. Okay. Draw the matrix. Uh huh. We make a grid where rows equal sequence. I get the 0. I get that. Now, first row and first column account for leading gaps. Fill the matrix. Now, you get 1, you get 2, oh, you get 3, you get 4, you get nothing. Pick the maximum on these 3. Could you show me how it's gonna look like in the matrix? No water. I got this part. Oh, I did understand this now. Fill in the matrix. I don't need the okay. You get a 1, you get a 2, you get a 3, you get a 4. Why is it 3? Oh, that's okay, that's same. And these two are same. But why are they minus 2? Why are they minus 2? Start at the bottom. Start at the bottom cell. 4, 6 equals 2. This one? Yeah, this 4, 6, okay. Trace diagonal when matching match/mismatch up to the gap in sequence 2. Left for gap in sequence 1. is this mismatch 0? And why is this mismatch -1? Why is this mismatch -2? I understood that 1 goes for the matches and -1 goes for mismatch, but I did not get the zeros, the -1s, -2s in the matrix. Just some water. That's what I thought. That's what I thought. We add an extra row and column for the gaps marked as minus. First row, cumulative gap penalties for inserting gaps in sequence 1. Why we use linear gap penalty? We'd use linear gap penalty of -1, moving right in the top row, okay. Add a gap, subtract 1 each time, moving down, subtract 1 each time, okay. Fill the matrix, each. What? Let's reset a time for 30 minutes. Okay. One, 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 one. Diagonal, one, match. I understood the diagonal being one and a match, but the left and up. I just didn't understand. If I start writing, how is it gonna look like? We're at cell 1 1. Cell 1 1 would be. This is 0 0. Like 0 1 2 3, 0 1 2 3, 1 1. That'd be 1 1, right? Yeah. Comparing row letters. Row. Row letters. T. With column letter 3. Three possibilities to compute the best score. Diagonal. This aligns the current letter from both sequences. This aligns the current letter. This aligns the current letter from both sequences. Yeah. 0 plus 1. 0 plus 1. 1 because T matches T. Uh-huh. Up. This represents introducing a gap in the column sequence. Column sequence, that would be the. Okay, yeah. I get it. Meaning we skip the current row letter T and align it with a gap. 0, 1, add the gap penalty 1. Again, I did not register that. Where's the study mode? Education. Huh? I thought we had a steady mode. Could you explain this using the matrix on the side? Because I'm still not getting it. Diagonal 0 0 match plus mismatch. I don't get it. What do you mean match plus mismatch? Fill 1 1. 0 1. 1 2. So T A. Okay, this one, right? Oh, where is it? Yeah. Diagonal 0 1. I don't just don't get again. You lost me at like Phil. One and you are going for 0 and 1. Also, what's with the plus match or mismatch? Like 1 or minus 1? It's just. Could you explain again? We have three options. What do you mean up? What? For 1 1, insert a gap in the first column sequence. How does the gap gonna match anything? understand. Fill cell 1, 2. So 1, 2 would be 1, 2, TA, right? This one. Now we have three options according to GPT. We have diagonal, align both letters. What? Why is this involved when you are filling this one? I don't get it. Why is the 0, 1 involved here? Diagonal score equals -1 plus -1. Okay. 1 equals T, column 2 equals A. Diagonal. Like, are we going like this? What? We want them to be diagonal. And just a minute. -1. Oh, wait, left. left, up, etc. Because when I read them, I just don't have any context. Ow, 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 ow. We want to fill cell 1, cell 1 2, that is this one, right? 1 2, which aligns row 1, yeah, column 2, this little guy, identifying neighboring cells. In Needleman Wunsch, each cell depends on 3 neighboring cells. Okay, I did not know that. Diagonal. I minus 1, j minus 1. I minus 1 is 0. J minus 1 is 2. So this one. Okay, I understand this now. Okay, now I understand what the diagonal was about. Align both letters, row and column. Up. I minus 1. I minus 1. J. So it's this one. Insert a gap in the column sequence. That inserts a gap in the column sequence. How? How does that insert a gap? Now that inserts a gap in the row sequence. J minus 1, so that's... so we can do this, we're looking at these, okay, these 3. Okay. Now I understand. Now, so for 1, 2, diagonal is minus 1, up is minus 2, left is minus 1. Yeah, that's why scoring. Yeah, so this one is a mismatch. So if we apply the mismatch, it's going to be minus 2, minus 2, minus 3, 0. So the maximum value makes the most sense. However, I don't know. So left makes sense here. Insert a gap in the row sequence. I don't get that fully, but okay. I understand that. Now I need to know, what does this mean? but the I don't understand why the maximum value is took, and what does that mean that left cap in the row sequence. It look like because understanding what left means in the is crucial. Okay. Yeah, and I don't understand what that means, okay? What the three directions mean. Diagonal align the current letters from both sequence that is a match or mismatch. Insert a gap in the column sequences. Insert a gap in the column sequence. This means we skip the column letter A. Let me right back. So, up Insert a gap in the column sequence. The column sequence. This means we skip the column letter A and align T with the row. Align T in a row. Uh, uh, uh. So we're putting the space here. Insert a gap in the column sequence. Column sequence. This means that we skip the column letter A and align T in the row. Align T in the row. We got one. We skip the column letter A. So we're putting the gap here so that the whole thing moves. If I understand this. Yeah, that's what they're doing. Insert a gap in the row sequence. This means we skip the row letter T and align a gap with the column letter A. Like, where would you insert the gap that makes a match? Mhm. Take the maximum because Needleman-Wunsch is a global alignment algorithm, and maximum score gives the best cum- cumulative alignment up to that cell. Up to that cell, okay. We give one for match. 30 minutes. Push up. Please reset a time for 30 minutes. I really don't know. Take the maximum because Needleman which is a global alignment algorithm. The maximum score gives the best cumulative alignment to the cell. We are aligning a gap in the row sequence. Row letter T is skipped. Okay, I could you visually show me what the up and left looks in the matrix? I don't understand. Hey yo, Devoto did appreciate for checking out the stream. Visualize up and left in the Needleman Wunsch matrix. We'll focus on the first few cells so that you can see how gaps are represented. Initialize the matrix's gap penalties. Represents a gap in the beginning. First column are initialized by cumulative gap penalties. Now, like show the whole sequence with the gaps show both show both showing the full sequence. What? Show me how this looks like. Again, show me how it looks like in the matrix. With the full sequence, not just the gap and the neighboring term. Clone open commander and Devoto did. I refreshed the chat. I'm guessing you don't mind, right? Yes. +1, yeah. Yeah. Show me the full. Could you show me the gaps with the whole matrix? Stop. Just the bits. Like, show me the gaps for up and left separately and how it looks for the whole matrix. And right now just focus on the matrix. Yeah, matrix. It's so annoying. It's 1, 2. What is this exactly? I'm kind of understanding what's going on, but still ChatGPT is not understanding what my question is. Perfect. Let's focus only on how the full sequence looks after inserting gaps. Again, why would you stop at here? Go the full. Okay, you just cancel the term. Like, there's no A up here. That's how you treat it. So up looks like. So you just erase the term. That's not a gap. How's that a gap? Oh bro, this guy don't get it. From the looks of it, you are erasing the Hold on. Not. It does not look like gap. Come on, fast, fast, fast. I need to bring another AI. It's thing is taking too much time. Idiot. Okay, it worked. It worked. Uh, no. I see exactly what you're confusing. The way I wrote it made it look like letters are erased, but really the gaps don't remove any existing letters. They just insert a blank space. Why is there 2T right now? Deep Six is cooking. Did you understand my question? I gotta ask this ChatGPT. You leave me no choice. You want to see the full sequence of gaps that would appear when calculating 1, 2 in the needle, yeah, not just isolated gap moves or single cells, but showing how the entire sequence look. That step depending on whether you choose yes. So show me the 3 cases. Diagonal. I don't think you have to show this one because it's just the normal one. Show me how the I'm talking. this matrix would be affected when the left since you're a beginner, I'll explain everything from ground up. Sequences X, Y, the scoring scheme. Okay, this time DeepSeek gives a different form of scoring scheme. I think this looks a bit complicated, but this would give you more correct answers. No. Sequence 1 TAGC. Okay, you include a space at the first term. Zero, 2. One. Just a minute. Now I understand how the gap is made at the first place, but why is the gap made at the start if we're cross checking the second and first position? Like, is the gap always at the start? Okay, this kinda makes sense, as now after the gap introduced, the AAs are matched, but are the gaps only introduced at the beginning? Like, why not? that should also give in the same result of match. Understanding the goal. Global alignment means we align two sequences from one end to the other. We want to find the best way to line them up, allowing gaps to maximize the final score. Alignment algorithm is the algorithm in a nutshell. The Needleman-Wunsch algorithm uses matrix, a grid, to systematically explore all possible alignments. We fill this matrix cells by cell. Each cell represents best score by aligning I. To calculate the score of any cell, we look at three possible ways the alignment could have ended. From top, gap in X. Gap in X. X. We align a gap from X with the character J from Y. The score is the score from cell above minus the gap penalty D. Mm-hmm. 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 From top, diagonal it's 0 0. TT, yeah, diagonal is 0 0. From top, 0 1. 0 0 1. It's minus 2. Minus D. D, what is D? Gap penalty, okay. Okay, if you add a gap, you give it a form of penalty. So how was the gap? 0. No, x-axis 0. Y-axis 1. 0 1. So we introduced the gap here. Yeah, instead of 0 0, we put a gap here. So that's the top. That's what means for top from left. So 0 0 and 1. Wait, 1 0. That's okay. These three are the positions that you consider for this point. So out of these three positions, diagonal makes the most sense. Plus S. That's a match. So it's two highest value. Okay. Now for cell TA. T A T A. This one. T A. 30 minutes. God damn it. Push ups. So we're going diagonal, like 1 2. Okay. So so okay. If you go like this, it's similar, but we're okay. Like, if we go here, what are the three numbers we got? We got the up, top. That would be 2. Yeah. 2 minus 2 minus 4. 0, 2. That's minus 4. Again, we start from 0. How is this gap looks like? How does this gap look like? The Needleman Wunsch gaps aren't freely inserted anywhere. They're inserted strategically as the algorithm fills the matrix. Here, why the gap shows a beginning instead of between T and A. How the algorithm works: the algorithm fills the gaps cell by cell, row by row, column by column. Looks at three neighbors, future letters, yet it only decides based on the current neighbors and scores. Why the gap appears in the beginning. So the gap is placed so far. Okay, it's just to match what we're having right at the moment. That's okay. That makes sense for inserting the gaps at the beginning. Why not T and A? The algorithm could introduce gap. Where the gap is placed depends on the traceback, which you Okay, traceback. I think that's important for the traceback. From top. From left. Am I missing something like TA? Yeah. From top. That would be, how is it zero? That's 1 1 top. This is diagonal. That is 0 1. No, okay, diagonal is 0 1. That was correct. Left is 1 1. That don't make sense to me. Up is 1 1. That makes sense to me. Mm-hmm. So, what's the question again? Give two sequences, compute all the optional global alignment using Needleman with linear gap penalty. I shouldn't have closed it. Mm-hmm. So we give values for matches. I give 1. For mismatch, I give -1. And for gaps, I give -2. Ah, it gets more complex after this. diagonal, right, down. Okay, I gotta charge this. This guy full. Yep. Hey sir, set a timer for 30 minutes. What is this? So what are the two sequences? Five, six. Four. T. D A G C. P A G C. TAGCCA. TAGC. Row. Matching score. +1. Mismatch score. -1. And gap penalty. -2. Yeah, gap penalty -2 is okay. So I used match score +1. Mismatch. Okay, it doesn't matter. -2, -4, -6, -8, -10, -2, -4, 6, 8. Yeah. So, cell 1, that is TT. Top, left, diagonal. So top is -2. That is uh 1 0 0 1. For me it's gonna be 1 0, right? I'm having a slight issue with I took the longer sequence as the x-axis and the y-axis. So like if you write 1 2, it's gonna be why did I put the brackets if oh okay, I hit somewhere something really stupid. Usually written vertically. Ah, okay. So we start with writing vertically. I did not know that. I usually go for horizontal. Mm-hmm. Top. That's 0 1. Why we have to change it compared to math? Like why can't we just use the same thing? According to the top would be 1 0. Why is I here? So so according to the graphs I have done, the is the x-axis that is here j I and vertical j, and when we write it's I comma j x axis term y axis term. Now for this you just completely switched that logic. Okay, now you made this one the x-axis, this one the y-axis. Okay, okay. That's okay. For cell. Okay, now let's see. From left, so -2, right? That would be 0, 1. Yes, top 1, 0. Okay, now it makes sense. Okay, okay, it makes sense. This is more like it. Oh, my hands are getting colder. You know. Oh man. Why is it taking this long to. So. I don't think this subtraction or addition matters, right? As long as we stay consistent, yeah. Matrix X. You're absolutely right. The gap penalty handling depends on how we define the scoring system. So where's me? What does it mean? Don't give me jumbled words. You know what? Maybe there's an explanation on YouTube. I forgot YouTube. I forgot YouTube. 12 minutes, 5 minutes, 35 minutes.
We are going to align two sequences. To complete this task, we must remember a few simple things. First, leave a space on both sides before writing the sequence.
Yep.
Second, we must assign the gap values in both column 1 and row 1. The following step is to complete the matrix. This is the direction for filling it. Next, and most importantly, how do we fill the matrix? To fill out this box, let's call it box number 1. Values will come from 3 directions: top, left, and diagonally. In light of these considerations, we fill in the boxes in the given example. Every match has a value of +1, every mismatch has a value of -1, and every gap has a value of -2.
That was the one I chose.
So, first, we add a gap position for columns and rows, and then we write the desired sequence. Then, by progressively adding the gap penalties, assign the gap values in both the first column and the first row. In this case, the gap penalty is -2, and the first row and column will be filled as follows. Then we must fill in box number 1. This requires us to consider 3 values: top, left, and diagonal. The top and left values represent the gap penalty, while the diagonal value represents match and mismatch. It means that when we take values from the top and left sides, we add a gap penalty to them, but if we take values from the diagonal side, we add a match or mismatch value to them.
Again, I forgot.
Represent the gap penalty, first column and the first row. In this case, the gap penalty is -2, and the first row and column will be filled as follows. Then we must fill in box number 1. This requires us to consider 3 values: top, left, and diagonal. The top and left values represent the gap penalty,
Yeah.
while the diagonal value represents match and mismatch. It means that when we take values from the top and left sides, we add a gap penalty to them, but if we take values from the diagonal side, we add a match or mismatch value to them. So, to find the value of box number 1, we start with the top side, which is -2, and we add
What? This -2?
gap penalty of -2 for every top movement, so the answer is -4. Then we take the value from the left, which is also -2, and add it to a gap penalty to get -4. Finally, we take the value from the diagonal box, which is 0. As we all know, taking value from the diagonal box leads to the addition of a match or mismatch penalty. In this case, t corresponds to t, so we add 1 to 0 to get 1. Now, from all of these values, we will choose the highest number and place it in box number 1. Similarly, for the next box, we take the value from...
Let me see. So it's a -4. So we got the top one, so it's -4, -2, and this one it's 1 -2. That's -1. This one is -2. And is it a match though? Diagonally it's not a match, right? So it's mismatch, -2, -3. So we're getting -1 here.
Top side and add a gap penalty, yielding -6. Next, we take the value from the left side and apply a gap penalty once more, yielding -1. We took value from the diagonal box in the last
Okay,
step.
I'm getting it.
And now we must add match or mismatch value.
Mismatch.
In this case, t does not correspond to a. So we add the mismatch value, which is -1, to get -3. Fill the entire matrix in this manner to complete the second step of the algorithm. The final step is to track back to determine the best alignment. Backtracking begins in the bottom right corner and moves to the top left corner. If the two letters corresponding to the box are the same, we proceed diagonally. If the letters are not identical, we will proceed to the highest value on the top and left sides. So let's start backtracking. As I mentioned earlier, if the two letters match, then we move diagonally. A matches with A, so we move diagonally. Next, again, G matches with G. Again, move diagonally. C does not match with G, so we move toward the left or top, where we find the highest number. We have 0 on both sides, which means we can move either way. Now, C does not match with the letter A, so we move toward the highest value either on the top or left side.
Top.
We've got 2 there, so we move toward that. On the second alignment, A does not match T. Again, we move toward the highest value. Now A matches with A, and T matches with T, so in both cases we move diagonally. The possible alignment should be as follows. Don't forget
Possible alignment.
move diagonally. The possible alignment should be as follows.
TATGA.
Don't forget to subscribe for
That's just basically you just wrote
The possible alignment should be as follows.
TATGA, TACG. Yeah, you just wrote these two, like, what?
Don't forget to subscribe for more informative videos and click the bell icon for the most recent ones.
Not gonna lie, bro, you deserve a sub. That one's in Python.
Hello again, it's Professor Hendricks, and if I had to name a class of algorithms that was probably the most important for bioinformatics, I think it would be sequence alignment. But what exactly is sequence alignment? How do we do it? And what is it useful for? That's the subject of today's video, and I'll use Needleman-Wunsch as an example. A sequence alignment is an optimal arrangement of characters that maximizes the number of matches and minimizes the number of mismatches and gaps. A sequence alignment algorithm computes this optimal alignment based on a defined scoring scheme where there's a reward for matches and a penalty for mismatches and gaps. So here I have an alignment between two short DNA sequences. And as you can see, there are vertical bars called pipes indicating the matches, and there are dashes corresponding to gaps in either of the two sequences. Now, although each of these two sequences is one-dimensional, in order to solve the alignment problem and to compute an alignment like this, we need a two-dimensional solution. And this is essentially achieved by sequence alignment algorithms. Needleman-Wunsch is a sequence alignment algorithm, and like most sequence alignment algorithms, it uses dynamic programming. Dynamic programming is a general category of programs in computer science that essentially solve the problem at hand by dividing it up into smaller subproblems. In the case of sequence alignment, we align two sequences by first considering the subsequences within them. So in other words, if we had two sequences X and Y and we wanted to align them, the way we would do that is by first comparing the first two characters of each of those sequences, X of 1 and Y of 1. Please note that I'm using one-based indexes here, but after we compare the first two characters, we would then compare the first two substrings of length 2 and then substrings of length 3, and progressively build up our full alignment from these smaller subsequences. And sequence alignment algorithms like Needleman-Wunsch first start by building a 2D grid. In this case, I'm putting the sequence X as defining the rows and the sequence Y as defining the columns. So the index of X will define the index of the row, and the index of Y will define the index of the columns. Before I can proceed to compute an alignment like this, I need to define a few things. First is a substitution matrix. Now, a substitution matrix can be a way of scoring two characters in our two sequences. In this case, I've defined a relatively simple case, S sub AB equals 1 when the characters A and B are equal, and negative 1 when A and B are different. If we expand this out into a matrix, it might look something like this, where our rows ACGT and our columns ACGT are essentially the same, and there's a 1 along the diagonal indicating a match, and negative 1 for all other positions defining a mismatch. Now for proteins, you might have something more complicated that might take into account the chemical similarity of different amino acids, but for nucleotides, we can get away with something simpler like this. Now, in addition to our substitution matrix, we also need to account for those gaps. Probably the simplest way to define a gap penalty is a linear gap penalty. In this case, our cost of a gap of length d is essentially that length d times a gap penalty parameter g. In this case, I'm using g as a negative number. Other programs will define g as a positive number and put a minus sign here. Now, this is the linear gap penalty. A little bit more complex is the affine gap penalty. Under the affine gap penalty, there are two gap parameters, and there's a gap open parameter and a gap extension parameter. The cost of opening the gap or starting a gap is g, and for any length d greater than 1, we also apply an extension parameter e. Now, if we take a look at NCBI BLAST or BLAST N,
Just a minute.
and we scroll down and open up their algorithm parameters here, we can see that they're using by default a linear gap penalty apparently. I think in previous versions they might have used affine, but this is what it says right here. The match mismatch scores are +1 and -2, but +1 and -1 is down here. It's not out of the realm of possibility. +1, -2 may be better, but for working out a dynamic programming matrix by hand, +1 and -1 is certainly a lot easier. Now they're using a linear gap penalty, but there's also
Okay,
affine gap.
this guy is explaining how to use the website. Right now, I just want to know how to do it in paper. Okay, so I kind of get it. I kind of get the logic. Now I need to do it on paper. Papier. Can I just delete the whole matrix? Delete this. Sequence analysis, assignment 4. Paste. Exercise 7, given 2 sequences. Compute all optimal alignments. This is annoying. This is annoying. Stop doing this. Okay, let me just check this out. If I press print, what it's gonna look like. Nah, it's okay. Okay. So I'm gonna share my tablet screen and we're gonna find out how this shit looks like. We got T A G C, and we got T. Wait, I need to 0 0. So it's T A G C C A. And put the line there. Put the line there. Put the line there. Put the line there. Yeah. Yeah, it looks okay. It looks kinda good. It looks okay. I remember playing bingo back in school. 0 0 0 and match equals +1. Shit. Mismatch equals -1. Gap equals -2. So -2, -4, -6, -8. -2, -4, -6, -8, -10, -12. Now we go for the first position. How do I write this? Like, should I write the whole calculation? Okay, let's cell 1 1 left. Idiota. Get the up, left, diagonal. And for up and left, we are considering the. I'm sorry, people. I did not see that the screen did not share it. Okay, now we got it. So up and left. Mm. So up and left, it's -2 plus -2, which is -4. So -2 is part of this. Like this -2 is this. And this -2 is the gap penalty. The same goes for the left. -2 plus -2, -4. But for diagonal, it's 0 plus 1 equals 1 because it's a match. Even if it was a mismatch, I believe the diagonal would be the go-to. So it's a match, and highest value goes in. Therefore, 1. So that's the 1. Now I would do for cell 1, cell 2 1, right? Which is AT. Up, left, and diagonal. So up, how does the up looks like? Up looks like -4. So up is -4, -2 equals -6. It's a -4 plus 2, -4 plus -2, and the left equals 1 plus -2, which is think -1, and diagonal would be -2 -1. -3. Highest, so that goes there. And for the last one, I'm gonna do by myself. Cell, this would be 1 2 GA. Up, left, diagonal. So the up is up is 1, and 1 plus -2 -1, and left is -4 -4 plus -2 -6, and the diagonal is -2 -2 -1, because there's no match. You get it? You get it, man? You get it? -3, highest, always, always. So now I can do my own math, right? I don't need to do I can do it mentally. Come on. So this part, AA. So if we're going diagonal, it's 1 plus 1, that's 2. Now here, it's a -6, -2, -8. It's not a match, so -5. I think this one makes sense. -1, -3, right? So that one makes sense. -3. Oh Lord. Now this one, GA. How does that work? Think! GA, -5, 0, -2, 0. Now this one, -8, -6, -3. Is a match? No match. -5, right? Yep, -5 makes the most sense. Now this one, AC, -7, -7, -4, and this one is -2. Now it's TG, now no match, so -1, -2, -3, -3 makes sense. Yeah. If I think if you get some of these then it's gonna repeat, right? Yeah, it's gonna repeat. So it's here it should be -5. If I understand, it should be -5. I'm talking about this part. This part should be -5. Let me calculate. Okay. -3, -2. Yep, that makes sense for -5. Now this part, the diagonal, oh, not the diagonal. 0, -2. Yeah, 0 makes sense. 0, 0, -2, -2. Of, oh, yeah, of course, it's a 3, motherfucker. It's a 3. Now, what's the rest? What's the rest? -2. That's a -2. Is it a match? No match. -2, -4. -4, 3. That's 1. Huh? 1. 1 goes here. Now for this. -5, -10, -8. -7. -7, -9. CT. Yeah, -7 makes sense. This one, AC, -2, -4, -7, -2. 3 minus 1 -1 -4 1 1 1 -1 -1 4. So no, is it 4 though? Yeah, it's CC 4. 4. That's the diagonal. That's it. I don't know. I don't know. I don't know. Let's see. What else do we got to find? 7, 12, 10, -7. How? -9. Yeah, -9. -2 minus. Oh, -4. Okay, -4 makes sense. That'd be -1, right? That'd be -1. We got no match, so no match. Wait. -1, -3, -6. So -1. That's the highest value. Now for this one, it's a CC. Oh, it's a match. It's a match. How's it gonna be? 4 -2. That's still 2. No. Oh, whoa, 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 whoa. These are 4 -2 is 2. 1 plus 1 is 2. So in both cases, it don't matter. It's a 2. That's all I know. Now, oh, this one, okay. It's a match. So diagonally, it's gonna be plus. It's -6, -6. Oh shit. We got -6 in 2 ways, so it's -6. And this one, GA, no, it's not match. -3, -5, -3. And CA, no match, so 0, -2, -5, 0. This is how the matrix gonna look. Yep, now it looks clean. So that's how the matrix gonna look. Now, do we have to do the back trace? Let me show the diagonal. This is the diagonal. the most match, if I understand. Right? Okay. Again, my doubt is, should I do this way or the other way? Let me check if it's correct. So I did do my own matrix. I want to know if I got the correct. Please show me your, I'll check your matrix values. No. How do I show you this? Copy. Now, do you think I could paste? It's an image. No text extracted. Copy as text. That's the only thing you copied as text. Show me your answer. I took match as +1, mismatch as -1, and gap as -2. For mine, the sequences are in opposite axes. We'll be right back. So it ends with 0, 2, -3, -1. Yes, this is what I got. Optimal alignments. Final score equals 0. This is what I found. But let me know, like, is it right? Is this the right way to do it. I don't. Okay. Now this one. How do you get to this? Trace back from your matrix. AC. Mm-hmm. 4, 6. 6, 4. Again. This, this, this. So it should be 4, 6. God damn it. You forgot what I told you? Again. Could you tell me I use the top horizontal one as x-axis, that is I. And the vertical one as the y-axis, which would be j. So you used the opposite, and should I change my form of the x and y axis? Because is this how mainly the softwares work? Or I can use my form and it doesn't. How do you know most of them are you? If they're using my form of convention, why not use it? Can I get the matrix on the side? So from left F 4 5 I equals 6. This is I. This is I. So we got a top, highest value top, diagonal, diagonal, diagonal. Is that how the traceback works? So traceback is just starting from the last point and following with the highest value. So we follow left, left, top.
Hi, ich bin Andreas. Du willst...
We are going to align. We must add map to the box sides, which means we can move yeah. So let's start backtracking. As I mentioned earlier, if the two letters match, then we move diagonally. A matches with A, so we move diagonally. Next, again, G matches with G. Again, move diagonally. C does not match with G, so we move toward the left or top, where we find the highest number. We have 0 on both sides, which means we can move either way.
Can I copy this? traceback. So we start from 0. If they are matching, we go diagonally. If they're not, go for the highest number. So it goes from here. If they are matching, we go diagonally. If they're matching, we go diagonally. If they're not matching, we go for the highest number. GG matching diagonally. AA matching diagonally. TT matching diagonal. Okay, so I don't get. I understand the arrow part.
Now, C does not match with the letter A. So we move toward the highest value either on the top or left side. We've got 2 there, so we move toward that. On the second alignment, A does not match T. Again, we move toward the highest value. Now A matches with A, and T matches with T, so in both cases we move diagonally. The possible alignment should be as follows. Don't forget to subscribe for more informative videos and click
We got the trace back. So I started from 0. Then again up. How do I interpret this? One. This would be mismatch or space. Okay, gaps. Uh-huh. 1. 2 gaps. But if it's just one gap, okay, that's a gap, right? -2, 1, -2. I didn't exactly understand this part. Alignment, it was just again, my question was. So, from the looks of it, the first one makes sense. Why are we considering second one? And if the C was in between the gaps, maybe we would have one more C match. So the DeepSeek just keeps on agreeing with me. You kidding me? Now we got 3 optimal bullshit. I still don't exactly understood the traceback part. That's a gap. And I believe that gap is for this one, up here. We put a gap. That's a match. Again, a gap. Yeah. A gap. Gap. And G A T. T A G C C A. I didn't fully understand this part, but it looks good. Well, that was the first question. Now we gotta do Needleman Wunsch algorithm with affine gap penalty. What is affine? I gotta look into those later. Well, that's it for today, YouTube. I will continue with the assignments later. I don't know if I would be here after. Like, I need to make. I need to know if I would be here. If I'm here, I'll continue with the biochemical kinetics, or or I have to visit a friend. It's a weekend, so I don't know for sure. Peace out, YouTube.